Hi everyone, so today I'm going to be talking about graphs for position, velocity or acceleration versus time. So this is one of those questions that often students are asked. For example, you're given a graph of, let's say, position versus time, and then you're asked when the velocity is going to be positive, when the velocity is negative, when the velocity is actually zero, and all these sort of stuff. So let's just start from let's start from the simplest version of the graphs and then work our way up and see how they work. So one of the graphs that we are usually asked about is the position versus time graph. This has I just want all of you to make sure to understand that this x versus time has nothing to do. If let's say this looks like this, all right, this curly curly wavy curve has nothing to do with how a particle moves on the ground. So it doesn't say that there is a car and just goes like this, because this shows the position of the object versus time. If this graph was like x, was like y versus x, sure, this line would look like that would be representing basically the path of the motion. But if this is given as x versus t, so position versus time, this only means that at what positions your objects is located at different times. So say, for example, we start from, let's just make this a little bit more elaborate. So let's see. Let's say all right, so let's say, for example, my object starts at t equals 0, at x equals 2 meters. So this is in meters, this is in seconds. All right, so suppose my object starts at 2 meters at t equals 0. So this is 1 point on the graph. And then after 5 seconds, then the object goes to, let's say, 6 meters in location. So 1, 2, 3, 4, 5 seconds, then this is gonna be 5. Now I do know the location of the object at these 2 points, but I have no idea about the location of my object in the meantime. So where my object was at, let's say, t equals 1 second, 2 seconds, 3 seconds, 4 seconds, and any seconds in between. So basically, I want you to understand that whenever you're having any type of graph for your position versus time, this has nothing to do with how actually the object, how the path of the object looks like. Because this is x versus time, this only shows the x component of the motion. So let's say, for example, let's suppose the graph looks something like this. So what you can see, from what you can see, basically from the graph, you'll see that the object was basically moving towards from 2 meters location to 5 meters location uniformly in this 5 seconds. That just by explaining the graph, that will show you there is this velocity of the object that was uniform. So the object was going with a uniform and constant velocity, because as you see, any portion of the graph that you take, the change in the x portion is proportional with the change in the t. Hence, because velocity is changing x over changing time. And then as you see, because this is a uniform line, this change is a constant number. That means that, you know, your object, the car or whatever was moving, it was moving with a constant velocity from let's say 0 seconds up to the 5 seconds. We don't know what's going on afterwards, but at least within that interval of time, we are able to express how it looks like. So that's that. The other thing that I want everyone to understand is that as you see, this velocity is delta x over delta t. So if I want to use little intervals, so let's say not 1 second, but the times that are very, very close to one another, like let's say this time and the time very next to it. So as you see, as I squeeze these two times together, what happens to my location is that the location gets squeezed together as well. So basically, because velocity is change in delta x over change in time, it's as if on the graphically, it's as if I'm basically doing rise over run. As you know, rise over run is the slope. So that just tells us that this velocity is the slope of x versus t. All right, just make sure you understand this point. So as you see, this line has a constant slope, hence constant velocity. All right, so now if I go back to my first drawing for the graph, where I had let's say some curly line, then as you see, the slope for this graph of x versus t is changing at all times. But at any given time, if I solve for the slope of that particular time that I'm interested in, then I can get the velocity of the object at that particular time. So that's essentially what graph of position versus time means. Now, if we want to go ahead and do so if you are, so this part is for like people who are having physics that are calculus based. So suppose I know the graph of x, the equation of motion of the object in terms of the time. So the equation of motion is position in with respect to the time. So let's say it's 5t3 plus 2t minus 10. All right. So if the object's position with respect to the time is expressed by this function, then because velocity was change in x over change in time, that just means that if I squeeze those two times, I can rewrite, so to speak, the velocity as dx dt. This means the derivative of x with respect to the t, and that gives me the velocity of the object at any given time. All right, so if I'm looking for the velocity of this object, then I have to do dx dt as I just said, and then just that simply just means that, you know, we're having d dt of 5t cubed plus 2t minus 10. And then that just means that derivative of 5t cubed is 15t squared plus 2, and then minus 10 is just a constant, so that doesn't survive the derivative. So the velocity of the object whose equation of motion is given like so, is given by 15t squared plus 2. Now if you are interested in the fact that what this object, when does the object stop momentarily, then you have to set the velocity to 0, and that gives you the times at which the object stops momentarily. As you can see from this equation for velocity, you'll see that this object is not actually stopping momentarily at any time, because if you set this to 0, then you get negative times, which is not physical answers. So the equation of motion of any object that looks like this means that the object is not stopping at any moment in time, so it just keeps going. However, if I had this negative for the 2, then this would be negative, then this would be negative, and then I would be able to get 2 times for my at which the velocity would be 0. One of the times would be negative, which wouldn't be physical, the other would end up being positive, and that would be the time at which the velocity would be 0. I hope this makes sense. If you have any questions or comments, please leave them down below. Subscribe to the channel so that you get updates on the videos. If you request any any special video to be made, I'm more than happy to do that. And take care and share that with your friends so that everyone can benefit. Bye bye.